Hello, everyone, and welcome. It's time to learn yet again. And we're going to step up the difficulty again today. We have a two-story, sort of. It's two-story, really, because it's got this thing. But the whole building isn't two-story. So here's what it looks like. This is a triplex that I just threw together the other week for a good friend of mine who likes real estate. This is what it looks like on the outside, on the front. This is just a concept drawing, but it's good enough for us to frame. So the front looks like this. These are two symmetrical buildings. The right side, left side are symmetrical units, and the center is its own style of unit. The back looks like this. There's all this like upper floor here on this side, and the back's just the single roof plane. That is the look. And here is what the roof looks like. So that's what we're working with today. And I'm going to be bouncing back and forth between the roof plan and ceiling plan a little bit. So we're going to get this sheet out of here because we don't need it. And we're going to flip these around so that the roof is on top, because we're going to start with the roof. So here we go. There's our roof. Okay. Hello, everybody. Now that we're organized, my name is Sam Stevenson. I have been obsessing with framing and construction for the past 5 years or so of my life. And I'm here to show you guys how I will tear apart this building in my brain and show you where I'd put all the framing. That is what I'm here to do. So quick little chat shout out, because we got Mr. Centurion in the chat. Hello, 54 Cent, my friend. How's it going? Thank you for showing up. Good to have you. Hopefully you learned something tonight. This is going to be a good learning opportunity. This is a little bit more thought involved, because like the more contemporary or modern you design a building, and the more these roof planes flatten out and stuff, things get trickier because you have almost no room to brace because you have almost no attic. So that makes things difficult because you just don't have any room to do anything. So that's what this is going to be. It's pretty difficult. Excuse me. I need to make sure I've got a... No, screw it. Who needs water anyway? All right. So you're going to learn how I frame this. Tools we're going to use are scale and highlighters of various colors. That is all we need. We're going to use this 1/4 inch per foot scale on this drawing, and we're going to frame it on up. This is the roof plan. I already showed you what the walls are on the ceiling plan. And basically what we're going to do is we're going to take all of the weight from up high in the building, and that's a nice block-like shape. And we're going to use beams, headers, posts, studs, you name it, jacks, all that stuff to take weight that's up high. We're going to follow the load path down through those wood members into the foundation below, and that puts it in the ground. That's our job, is to make sure that we don't get squished when we walk into a building. So that said, let's think about the structure here. Now, there's no notes on this. Actually, there might be some on this sheet. Let's see. I didn't label it because I didn't make a full like plan set out of these. This is just a concept. This is all 9-foot ceiling. That's all 9-foot ceiling. So that makes it easy. All right. Those are the plate heights. That's what we're working with. Okay. Let's get right into it here. Wow. Ooh, excuse me. I don't know why I'm yawning. Do some push-ups before I do this or something. Okay, so roof plan. Let's take a look at this roof. And first thing is, do we see any ridges, hips, or valleys? No, we don't, because there's not any on here. because a lot of times contemporary roofs like this that have these big flat planes of roofs, they just don't have hips, ridges, and valleys because like that's just not the kind of roof planes we put into the plan. So good news is we don't have to support any. So we're good. On this entire back roof plane, we're supported at the wall all the way up to all these walls back here. And you might ask, well, how does the roof held up on the wall? And you do that by putting a ledger on the wall. So if you've got a bunch of studs, that's a stud right there. Nice curvy one. And I got a roof going up like this and it lands on the wall. You'd attach a board right here and you'd attach it to all the studs. And then you would just attach your, rafters to your board. And that's called a ledger. So that takes care of that. So we're supported on the high end and the low end. Down here out on these porches, we need beams because there's a porch. I kind of missed there. So there'd be some beams there defining the porch. There's a beam there because we're missing the wall. If you look at this plan, you can tell there's a patio right there. Okay. So that's pretty simple. Low end, we're good. Now, I will tell you, if we're using 2x6s, 24 inches on center for the roof, they're not going to make it all the way up to this wall without some purlins. So what you want to do is find where I put the scale. There it is. All right, so let's start on the back and get an idea here. So that's a 22 foot here to here, and that's a 32 foot here to there. So we can split this right down the middle if we do it that way. Now remember, see this pitch here? You can't read it, but it says 112. That means for every 12 inches over, I go up 1 inch. And that's a very low slope. And so if we move in from the exterior wall 12 feet, we're only up 1 foot. And that doesn't give us a lot of room to work. So basically, all of our bracing has to go straight down. That's the way you got to look at it. If there's a wall, we can brace. If there's not, we can't. So how do we deal with that? Well, I'm going to tell you right now, we're going to need some beams. Let's just look at this little section in here in the middle first. If you're on the back wall and you're a rafter, you're going to start at the wall. You can come up here. You're going to land and stop on that wall. That's what they're all doing in this little section here. And so what I'm going to see is that any one of these spans, pretty much over any of these walls, I'm going to use bracing. And I'm even going to need to put a beam probably right here, because if I go from this wall to this wall, that is over 11 feet. Yeah, that's 16 feet. That's 10 and a half feet. Okay. So that's pushing it, but luckily that wall's right in the middle. So here's how this is going to work. Rafters are going to go like this. We're going to need to put braces. We'll do a purlin line right here on top of this wall, on top of this wall, on top of here, on top of here. Oh, wait. Well, we can ignore this one. We'll just go across, and then we'll take a beam. We'll put a beam in here. Now we'll just basically say, hey, yeah, we're going to brace straight down. And when we're bracing straight down, we just draw the dot because there is no, nothing else you need. So that'll hold up all the rafters in this area. Now you got to keep in mind when you're bracing, it's fine, but because I got a beam in here, I got to think about two things. There's a beam. I'm about 12 feet in. So here's where that measurement starts. So the wall's right here. This is our rafter. That's the bird's mouth cut of the rafter. This height right here is what I'm referring to. So that's where the roof pitch starts. Therefore, if there's a wall over here, and this distance between these walls is 12 feet, then this distance to right here is 1 foot because of my roof pitch. So I actually have 12 inches of space here. And so when I think about this beam, I don't want a dropped beam. I don't want it sticking down below my ceiling because no one likes to see that. So I want to know that I have, is this beam going to be taller than 12 inches? Because that's all I have here. And the answer is it will be just fine. It'll, this is a very short span and it's holding very little weight. So you could probably use some 2x6s or 2x8s sandwiched together. You'd be good. Glued and screwed, baby. So yeah, it would actually probably only stack up to about this tall. That'd be your little beam. And then you take a brace and you would just, do that to the beam. So that would happen right there. We'd be fine. There's plenty of room. But maybe somewhere else, we're going to have to do something else. We'll find out. Okay. So I happen to know that that's good. And that's how I'm going to do that here. So I'm going to write between this section, we're doing 2x6s, 24 inches on center. And I'm going to write that here because I don't know if I want to do the rest of the walls like that. I might do those differently. So, because like I got some wider spans in here and I would rather just use a bigger board than a bunch of braces and beams in this case. A lot of times in these contemporary style homes, you're just going to increase the repetitive member size. The repetitive member is the piece that's like lots of them, rafters, ceiling joists, whatever. You just increase the size or decrease the spacing to improve the span. This one's all the way up to 18 feet. So I don't even know. I'd have to check the table, but we can make some assumptions because, you know, this is not a real framing plan. So let's do that. Let's do this side, and which will end up being this side as well. In fact, I'm only going to draw one side because they're mirrored. Save you guys some time. Okay, so rafters are going to go this way because that's the way the roof is sloping. So that's what's going on. And then purlin lines, I'm like, okay, well, there's a wall right here. So I'm going to be right on top of the wall. I got a wall here. And then I'll check this guy. That's 10 feet. That's, wait, that's the wrong scale. I was like, there's no way. There's no way that's 10 feet. There we go. That's 8 feet, and this is 12 feet to the wall. So it doesn't quite cut the cheese, and that's okay because I think I'm going to beef up these guys as well. That's a 14 foot. So that's like the 2x8 limit. And this is a 17 foot. So like that's probably like the 2x10 limit. So let's assume those are at the 2x10 limit. So we're going to take this section of rafter, and these are going to be 2x10s at 24 inches on center instead. We're going to do that instead. And that's going to make this easier to just like support it here, and we know we're still good. So we'd still put our braces in because you still got to brace down to the walls, right? Hold up the spans. And we'd be okay. We could reach from here to here. We don't need anything else in the middle. I'm just trying to avoid putting beams in. If your preference would be for the 2x6s, then great, but you will need to put beams in here. And it's just a different way to do it. So one thing people might wonder is how can I have one roof line? I use 2x6s here and 2x10s here. If I got a bird's mouth like this, how do I keep my roof plane flat? Because now one of these rafters is taller because it's a 2x10. Here's the answer. Is you don't cut out the depth change from the bottom. You wouldn't cut the bird's mouth on the bottom of this like this. Like what you'd end up doing is this would not stick up. You would use the 2x6, and then you would actually plane the top of the 2x10 with the top of the 2x6, and you would cut more out of the bottom of the 2x10, and it would look something like this before you cut it. Because let's say this is the 2x6 line, and your bird's mouth was right here on the 2x6. Well, you'd basically just take this notch out of the 2x10, right? I'm not done yet. You take that notch out, and then it would fit on the wall, just like the 2x6. But now I got this big hunk of wood, so I'd cut this off. I would trim this off, however is needed to like form the soffit, however that's detailed. That doesn't matter. You just cut it off. And on this side, this works out great. But if I do this and I put this on the wall, I now have this chunk of wood sticking into my room. See that? That's my ceiling right there. That's my ceiling line. So I'd have this chunk of wood sticking into my room. That's not good. Well, how do you do that? Well, you just take the bird's mouth and run it over horizontally until you're good. Now, this works in a room with a flat ceiling. If you had to vault the ceiling, you'd have to be a little more careful about what boards you're selecting. In this case, you might keep 2x6s because you really want to maintain this corner because the sheetrock is going up here. And this is all interior room space. But in this case, we can just cut this off. Anyway, hope that was a little bit helpful. That's how you put a different size board on the same wall and maintain the flat roof plane. You just cut the bottom of the board differently. So that takes care of the rafters, braces, and stuff on that side. Let's talk about up here and in the middle. All right, let's do the middle first. Same thing. We got a 112 going from this wall to this wall. One rafter. Well, actually, let's just draw all the rafters because small space. That's the rafters. We got the same thing going on over here. All right. So what are we going to do? Well, I got all kinds of walls to use in here. So I'm going to, but I want to use 2x6 24 inches on center. But check this out. This one rafter or any that are in the hallway, and the hallway, my friends, is 4 feet. So there's at least going to be one, probably two in here. I'd look at this and I'd say, that's like a 17-foot span from that wall to this wall. That's not going to work. And so I'd say, you know what? You're right. I'm probably going to go in about like 11 feet or so and put a beam across these. And then I will use that. And I'll say, hey, when I'm bracing this off, I'll do purlins here, and honestly, actually, I take it back. I wouldn't put that beam there because here's why. The purlin supports need to be 4 feet on center. The purlin is like a little mini beam going underneath all these rafters, right? So if I brace this off, I can actually cross the 4-foot hallway with my purlin and no one even cares. And if I'm doing another purlin line right here, it doesn't even matter. I've got my span taken care of. So this would be super easy to frame. There's not even any beams up here. Now, this plan has not been optimally designed for like an HVAC system going in here. This is a concept. And so there'd probably be some things changed in order to do that. Like I put a chase in the center here for each side, but like that's not going to help a whole bunch. So you'd have to like think about where you're putting that in this building. But I don't think that's what you're concerned about. What you're concerned about is the framing. All right. Hello, Mr. Pumpkin. This side, all right, let's do this super easy here. We got 11 feet right here to here, so that's good. We just put a little purlin thing in here, throw some braces on it, support those guys. And then this wall is 11 feet to the end, so we could brace again on this wall. Mr. Pumpkin, my cat, is currently climbing in the piece of paper that I just set down on the floor. Okay, so we'd be good through here, but we're not good right here. But wait, don't chew it up, you turd. Okay, that's 12 feet across. So I can't quite make it to this closet, and ignore the thinner lines. That's from the floor below. I can't make it to the closet, so I'll just, see, here's the thing. I could put a beam in line with this one. That'd be fine. But if I do that, remember what I said up here about the height. Yeah. Okay, so here's what I did with this design. The roof plane right here is based on this wall, and then the ceiling height drops down for the stairwell, which is fine because it's a stairwell. The ceiling height's already super tall. So that's not a problem. And then it goes up from here. So from this point, I'm at the 9-foot ceiling, and I'm going to go up at my 112. And if I only go a few feet in from a really low slope roof, I'm going to end up over here somewhere, and I'm not going to have enough room. And so I'll have to make a special notch. So if I'm framing this, I now have to make 2 bird's mouth cuts to make this beam work. And that's annoying. So what I'd rather do is push this beam farther over. So I know when I put the beam in, it's far down below, and I can just take extra blocks and then, attach those. That's faster. So I'll put my beam over here somewhere. And then I'll do this doodad. Okay. That's how I'll do that. I get the same strength. Framing is faster. So that takes care of how we hold up our whole roof. Now, let's first carry over our beams into this plan, into this other plan. Let's do that first. Time to do some cross-referencing. If we were doing this in the CAD software, we would just copy-paste and we'd be done. All right, so on the second floor, we had the beam here for the roof, which means we had the beam there. And that was about it. I think that's all we needed. What did I do here? Oh, the purlin was there. I didn't need a beam. Okay, so first floor, here's what we're going to do. We had the patio I use a different color for, every item every week because I'm not keeping track. Okay, so patio beams. We got the porch beams up here in the front as well. Those are definitely holding some weight. And what else? What else? What else? What else? Ooh, one of your first ever. Okay, so this isn't notated, but it's in the picture. This balcony has a vaulted ceiling. There's no flat ceiling here. And so the roof plane that goes above this, I missed this before. There's actually a beam right here because there's no wall. So there's a beam right there to hold the high end of the rafters. I'll show you again in El Photo. That's now been chewed on by my cat. See this? That's upside down. All right. See this balcony right here? This roof has to be held up by something. And so there's going to be a beam tucked underneath it right in here somewhere. So that's taken care of. That's what I'm talking about. All right. So that takes care of this floor. Now that's copying all those beams down. Here's what we got to do. Second floor ceiling plan first. Let's just do that first. Okay. Look at all these spans. I don't see a single direction I could span that would go over the 14 feet. I'm obviously not going to go the length of the hallway. I'll do the short way. So if all of this is less than the 14 feet that a 2x6 at 24 inches on center can go, then I don't really care how the ceiling is laid out because 2x6s are good everywhere. So like 10 foot's the max span there. If this was side, well, there's no ceiling here because the ceiling is the rafters. Ceiling is the roof. Yeah, so I would probably just run my ceiling in line with all my rafters. Not right there, obviously. Stop it right there. And the same thing happens right here. The rafters are the ceiling. So I will just run these all forward. And run these all forward, just the whole thing. No ceiling, no ceiling. That's the ceiling plan. Done. Just like that. Super simple. All right. First floor. This is where we really got to pay attention to the ceiling because the first floor ceiling is the second floor system. All right. So we're going to either use floor trusses or TJIs or whatever. I mean, you could use lumber if you want. Nobody does that anymore unless you're like in San Antonio and people are like doing it for the cheap, which happens. But not for us. We design them with nice materials. So what do we got? Let's do this first. If I was a CAD guy, I would take an outline of this thing. And when I say outline, I mean outside of framing. I would follow outside of framing all the way around this. I'd copy it, I'd line it up, and I'd paste it. Now, because this house was designed by me, and I'm obsessed with framing, I specifically lined up these walls so that I would know, hey, you're going to save money on beams because your beams aren't crossing crazy spans. So I happen to know that this right here, it happens right on this. Oh, look, someone put a wall here and a wall here that are lined up. And like I could have left this wall off for the fridge, but when you get this far of a span, every like few feet that you can pull off of this means you're going to save a bunch of money in your beam. It's just spanning much farther because floors are heavy. Floors are heavy. Quick chat shout out, guys. We got Eugene. Hello, Eugene. Look at those cats. Look at those cute orange cats. We like orange cats, don't we, Mr. Pumpkin? Good to have you, Eugene. Hope you're learning. This is great. And then we got Wyatt. TJIs suck. TGIs. Hey, TGI Fridays. They had back in the day, they had those cups that if you poured water in them, they'd change color. That was pretty cool. But I think you meant TJIs, and that's okay. And you hate working with them. That's interesting. When I was a framer, I did not have to do that at any point. And so I can't speak with experience. But if I get my hands on them, we can relate. We'll see. We'll figure out what happens. That's good to know, though, that like they're probably annoying to work with. They're probably floppy and like you can't cut them easily because they're all like, web shaped. For those that don't understand, TJIs are a manufactured engineered wood product, and it's a floor joist with a cross section that looks something like this. This is usually made out of some kind of oriented strand board, and this is made out of some kind of plywood, if you want to call it that, but it's basically like an LVL. It's just a laminated base of the wood. It's just not solid sawn. So different ways of doing that. Got his chat here from they splinter, and there is a schedule for penetrations. I think penetrations, a schedule for penetrations. Yeah, you got to be super particular about how you poke holes in this, for sure. For sure. You know, they were kind of nice as an engineer when I was doing engineering plans, because you basically write a disclaimer on the plan that says follow the manufacturer's instructions, and we just don't need to worry about it. It becomes a manufacturer's deal. That was kind of cool. But yeah, they are tricky, but they're lightweight. They're lightweight. Hopefully that makes a difference. Let me know in the chat, Wyatt, if you'd rather work with floor trusses or TJIs or solid sawn lumber. What's your favorite? Let me know. Okay. So I was talking beams. So let's trace this out on here first. Let's do that, because we got to know the area that we are focusing on. So tell you what, we're going to basically trace it out by just putting the beams in. So I know that this beam was here, right across, close enough to being straight. I could use my tool, but I'm just not gonna. Okay, that beam crosses there. That will define the edge of the floor system. And then we got a beam that has to cross here. See this up here? Wall turns and goes this way. Lands right on top of that. And a beam here. And then look at that. There happens to be a wall surrounding the rest of the floor. The interior firewall is stacked on top of this firewall. And that's easy enough. The next thing we got to know is, where does this line happen back here? And if I'm looking, oh, wow, look at this. What a designer. What a designer, folks. Look who did this. Okay, so this wall has a lot of weight on it. How do I know it has weight on it? Because there's a roof sitting on it. And this roof sits on it. It's got like 15 feet of tributary width of roof, plus the weight of the roof, or sorry, plus the weight of the wall, because it's got dead weight, plus the floor system. A lot of weight there. And so whatever span, whatever's holding that wall has to be strong. And so originally there was only one wall right here. And this stairway has an exposed railing, so it like just kind of opens the space up a little bit more. There's no wall here. And so there originally was one beam that went all the way across this sucker. And I was thinking to myself, man, that's a long ways. That's a long ways for a beam to go. That's 22, 23 feet. So that'd be a chunky sucker. If you're doing this floor system, you would probably have to push the size of your floor system up and thicken your floor system, aka spend more money, to do this and hide the beam. Or actually, in this case, you could probably push the beam up and frame it into this wall. You could do that, but that just becomes an annoying detail for all your framers, and then your studs aren't standard, and just that's a nightmare. So instead, somebody added a post. I don't know if you can see it. There's a post at the corner of this stairway. And so it takes like 6 feet off of the span that this beam has to do. And now you put one beam here, one beam here. Everybody's happier. Isn't it nice to design with people who care about the framers? Okay. Plus you could put some cool cedar post or something right there. Look pretty fancy. So that's a box. Goes right there. No questions. Super simple. Yeah. Okay, so that outlines the floor systems. So we know the perimeter is getting down into the foundation. We're good there. The next thing we want to think about is where did we concentrate any weight? Did we not? We didn't really. There's only 2 spots that I'm sort of concerned about. So if this whole thing was just ceiling and rafters being like, supported like evenly throughout the walls, then we wouldn't really be concerned a lot with what the floor joists are doing below this, because there's walls that are like supporting it. So what I want to think about here is, I know there's actually a load line. This is load bearing wall. This is load bearing wall. That's load-bearing wall. Okay, and there's a concentrated load right here. So let's just look at this side here. So about actually in line with the end of the stairway, that's load-bearing wall, and in line with the front of the house, that's load-bearing wall. So that's good because this is all wall and this is wall. So if this was me and I was doing the floor joist, again, depending on which way you want to run your HVAC and stuff, you could change your orientations. But uh, I would probably just say, yeah, let's just run a beam in that floor system right there. It's going to catch all the weight from the roof. And let's just run one right there. It's going to catch all the weight over here. I'd probably just do that. And then on this side, there's a little bit of a load bearing wall that's like a little bit set back. But look at the span of your TJIs. So when you size a floor system, you size for the longest span, most difficult spot, and then the rest of the floor is just going to be that size. And so frequently everywhere else where there's more walls, it's super stiff, it's super over designed, it's fine. And so over here I'd be like, oh well, I'm going like 6 feet and then 6 feet. I'm gonna have a stiff TJI, they'll handle it just fine. So I'm no extra beams here, but I do have a concentrated load right here. And so what I'm gonna think about is, where is that load? It is 9 feet from the wall, which is actually somewhere right here. And that's good to know. Now, there's not a ton of concentrated weight because this wasn't spanning very far, but it is a beam carrying roof, and so there is going to be some concentrated weight there. So what I would probably do is I'd look at this, and with a slight extra concentrated load, of course, I would check the calcs, but I'd say just double up a joist. Double your joist in that one spot, and it's going to catch that load just fine. And that's going to make some people upset. Why is that? Well, this is why. Because look at what kind of wall this is. That's a 2x6 wall for a reason. This is a plumbing wall, which means there's a toilet vent, there's, sink, and there's this going on back behind here. So there's a lot of plumbing happening right here. And if you happen to double up the joist below this whole wall, guess what? You put a bunch of wood in the way of all your plumbing. So what I'd actually end up saying, if I was to specify this, I would say, yeah, double the joist, but use a blocked double joist detail, or just like space the joists out so they're just not in the way of the wall. So it like basically, if this was one of the TJIs, you'd put the other one right here like this, and then you'd like your subfloors on top of both of them, right? And then you'd put your wall right here, bottom plate, and then there's your wall. So your plumbing can come right down into this and you'd be fine. And then like every 24 inches or so, you'd put a block of something in between these, and that allows them to like share the load of the wall a little bit more efficiently. But you just put the blocks out of the way of the plumbing and it'd be fine. That's probably what I would do to be considerate for those plumbers. If the framers are kinds of people that are considerate for plumbers, you never know. All right. So this whole area, this is not the direction the TJIs would go, but I'm just showing, let's see, before I draw too much. Where is the stairs? Stairwell happens right here. So this blocks out the stairwell. So I'd have TJIs, and on this side, we're going up, so we'd probably put the stairwell right there off of that. Okay, so that'd be a beam. And then that would be defining of the floor. So that takes care of the ceiling in that whole area. There's ceiling, again, for the stairwell, the ceiling is this ceiling, which is actually the roof. So we don't got to worry about that. And let's take care of the rest of the ceiling. All right. I would like to go back to front because that's in line with my rafters, and that would just be great. So what I would do is, again, we don't have a lot of space in here, but if our rafters are starting back here, we're 1 foot high right there. We're 2 feet high right here. So we could actually fit a reasonable sized beam across here. So let's do that. We're going to put a beam across there. These spans are a little bit too much, so we'd put one beam right here, and then we'd just say, yep, run the whole ceiling. So now no spans are over 14 feet on this one, and that one's kind of pushing it. fine. What's this span? 12 feet. Okay. So in this case, I would turn this room just to be able to use the 2x6s. We'll do it here too. And this can go this way. It don't really matter. It's 6 one way, half a dozen another. It's whatever you're feeling, So just copy that, put it over here. That's how we'd run them ceiling joists on this side. That's what I'm thinking. And then we don't have any other crazy concentrated loads or anything. So this looked complicated because it was a 2-story with these like angular roof things going on. But like it was actually a lot of stuff pretty close together. So that makes things pretty simple. When we get into doing like the crazy homes, which I'm going to start hopefully designing here soon and throwing some together for you guys. The crazy homes with the multi-level and all that stuff is where things can get pretty dicey. So you'd want to keep an eye out for that. There's no attic access storage anywhere in this thing because there's no attic. Oh, excuse me again. My goodness. All right, that's why I'm yawning is because it's 8 o'clock. It's my bedtime, folks. So, well, it's 8 o'clock here in the central world. I appreciate you guys coming, spend your valuable time here learning. I hope this has been helpful. Please ask questions in the chat if you ever have questions on like where are you getting this information? How is this going? Like I'm just blabbing, and what I'm trying to do each time I do this is sort of start and explain everything from the same point so that I'm not like, leaving anybody out, that kind of thing. So appreciate everyone coming on. We got solid lumber from Mr. Wyatt. Even though it's got the warpies and all that funny stuff. Do you ever design with steel? I do a lot for steel for large spans. Ooh, great question. Yes, I can design with steel. It is a little bit like residential steel is usually not a big deal because you've got like some beams and some posts. On like commercial steel, that's an entirely different animal. I have no clue how to do any of that because that stuff's like that's software. That is software stuff at scale. I know how to do wood and pieces of steel. So if you ever have like a space where you need to fit a huge, super strong beam, but you don't have the height or the depth, but you have to do a really huge span, you would use a steel beam. And the steel cross section, of course, would look like an I-beam. That was a terribly drawn I-beam. There you go. There's your I-beam. And that's what you would do. And then you'd basically like, bolt a plate to the bottom or the top or bolt plates in wherever you need to like attach wood stuff to it. Or like weld it to steel posts and things like that. But like that's what you would do. And so yes, I have designed with steel beams, and it's literally as simple as like going to the calculator, Forte Web. I'll spell it out for you guys. Forte, that's an O. Forte Web. If you go to this website, I talk about how to do all of this in my framing design program. It's free. It's on my YouTube channel right now. Pretty sure it's been set to public. And this is where you would do all the calculations. And so if you just swap like, hey, instead of a 5.5 by 16 glue lam, throw in like a W15 something steel beam or whatever, however they do that. So yes, that's what we do. Happy Friday from Eugene. Thanks, Eugene. Good to have you, my friend. Why everyone at the bar watches the football game, and I watch Frame It Fridays. Keep it up, bro. Studio Shed and I are still in talks about you. Awesome. I love to hear it, my good friend Wyatt. That sounds excellent. I got some things cooking. As you guys know, I've been selling my ass off to the entire state of Texas. So as things come through, you'll get the updates from me, and we're all making it happen together. So appreciate you guys supporting the channel, and gig 'em. I'll see you guys on the next one. Let's take it out with some music by the one and only Green Observer.
That's the code.